Till now we discussed about generator action, motor action. Okay, in the sense torque will be developed, motor action, torque will be developed in both generator and motor. And generation, or generator action, which is nothing but induced voltages, will be there in both generator and motor. Okay, now let us consider generator, okay, and motor. Okay, in generator, if load is connected, how armature reaction is affecting and how that back torque will come, because by conservation of power, torque should be against to the direction of rotation. Let us see. Let me think of generator now. Okay, means I'm trying to combine generator action and motor action. Torque developed also, I will try to combine now. For example, this is N pole, this is S pole, so flux is in downward direction. Now let me have my conductor is being rotated in this direction. Okay, in a generator, direction of rotation should be specified by generator, and the direction of induced voltage has to be found by using right hand rule. Now see here, this is going to be N pole to S pole, means let me apply this right hand rule, N pole to S pole. Okay, and the direction of rotation is in this direction, direction of movement, because conductor is moving in this direction, so induced voltage will be inside, so induced voltage will be in this direction. Okay, these are going to be induced voltage. Now for this induced voltage, for example, if load is connected, okay, so the moment load is connected, what will happen? Currents will flow. Okay, as our previous discussion, in generator, induced voltage and current should be in the same direction, such that it will be able to deliver electrical power. So if at all, if load is connected, my currents will be cross only, because in generator, induced voltage and current should be in the same direction. Okay, so currents are produced like this. Now means already some field is there, and you are having current, electrical current. So whenever you have electrical current, automatically magnetic field should be associated. Okay, that magnetic field, current is in this direction, so magnetic field will be in this direction. So my magnetic field produced will be in this direction, Okay, now upon that, how my field flux is? Field flux is in this direction, N to S. Okay, so what is happening? My field flux is in this direction, and armature conductor current is in this direction. This and this is aligned here in the same direction. This and this is in opposite direction. So my net resultant flux is going to be, because of this opposition, my net resultant flux is going to be like this. Okay, so because of this, what will happen? My magnetic flux lines are stretched in this direction. So my torque developed will be in this direction. Now what is the direction of rotation? You are trying to move the conductor in this direction. Okay, so my conductor, you are trying to move in this direction, the speed, but because of the load connected, okay, let me tell you again. For example, if only conductor without having any load, if I am trying to move in this direction, nothing will happen. Okay, but now if you are trying to move in this direction, induced voltage will be there, and the moment you connect resistance, automatically currents will flow. Means that my resistor is going to absorb electrical power. Means my generator has to absorb mechanical power. Means that if you are trying to move in this direction, some opposition should come, such that in order to move, you have to push hardly, means that it will absorb mechanical power, which will be converted into electrical power. That is nothing but armature reaction, we can say. Okay, so means at no load condition, without having any load, you can easily move it, but the moment you connect the load, back torque will be produced. You are trying to move in this direction, opposition will come. Beyond the opposition, you have to move in this direction. Means that particular mechanical power will be absorbed, which will be consumed in the name of electrical power. Now let us think of stationary field. This is stationary field. Okay, now let me think of rotating armature, like your DC machine. as I said, this is generator. Okay, in generator, what will happen? You have to rotate the rotor. You have to rotate the rotor. So, for example, you are trying to rotate in this direction. This is speed. Okay. Now, if you are trying to rotate in this direction, my induced voltages will be, for example, in this conductor, my flux is in this direction. Okay. So, my flux is in this direction, and direction of rotation of conductor, because basically conductor is moving, so conductor is only moving, so conductor is rotating in this direction. So, my induced voltage will be inside. Okay. So, induced voltage here is going to be cross. Now, let us come back to here. So, this is going to be in this conductor, flux is going to be in this direction, and the rotor is being rotated in this direction. So, induced voltage will be in this direction. So, induced voltage will be in this direction. Okay. At no load conditions, it's happy life. So, means rotate yourself without any opposition, because at no load, once load is not connected, under that condition means electrical power output will be 0, so mechanical power input also will be 0 in ideal conditions. Now, let me connect a load across these two. Okay, then what will happen? Currents will flow, because voltages are there and you are connecting a load, so you are showing a path to electrical current. So some currents will flow here. Some currents are flowing here, means that you are absorbing electrical form of power. So this is absorbing electrical form of power. Generator has to deliver electrical form of power, so generator has to absorb mechanical form of power. Okay. Now, for example, once the load is connected, load currents will be aligned with the induced voltage in generator. So dot here, cross here. Okay. So the moment currents flow, whenever current is there, automatically flux should come. Okay. So means cross here, dot here, currents. Okay. Cross here, dot here, currents. So automatically my flux will be in this direction. Now flux has to come out here. You are sitting in the air gap. Flux is coming out like this. So it should be north pole of the rotor, south pole of the rotor. Okay. This will happen only once your load is connected. Now north pole will be repelled. North pole, south pole will be attracted. South pole, north pole will be attracted. So north and south will be attracted. So torque developed will be in this direction. Okay. So at starting you are trying to rotate the rotor in this direction, for which torque should be in opposite direction. Back torque should be there, such that this and this will oppose, in the sense a no load condition happy. But the moment it is load means some opposition will come. Beyond opposition you have to rotate. Okay. So back torque should be, in a generator, torque should be always against to the direction of rotation. Let me think of again generator. Okay. In generator, let us think of poles are in the rotor and armature is in the stator, like our alternator. For example, conductors are here. Okay. Now let me think of my poles. So in this direction. Okay. Let me think of this is N pole. Let me think of this is S pole. Okay. So N pole, you are sitting in the air gap. Okay. So in generator, direction of rotation should be fixed by you, and the torque should be against to the direction of rotation. So at no load conditions, happy you are rotating. Now if you are sitting in the air gap, flux will be coming out of N pole, and the field is getting rotated in this direction. Field is rotating. So relative velocity, if you observe, if field is rotating in this direction, with respect to field, current should be in opposite direction, conductor should be in opposite direction. So conductor should be in opposite direction. Now my induced voltage should be out of the board. So induced voltage here is going to be dot, induced voltage here is going to be cross. Okay. Now these are the voltages. Now let me connect maybe the load. Okay. If I connect the load, what will happen? Whatever may be the voltage polarities in the same direction, current has to flow, because it's generator. So my currents also should be dot here, cross here. This is voltage, induced voltage, and this is current. Now what do we know? Whenever you find electrical current, automatically associated magnetic field should be existing. Cross here, dot here. Okay. Currents. Okay. Because of currents, flux will come, not because of voltage. So currents cross here, dot here. So flux should be in this direction. So flux should be in this direction means that flux should be in this direction. Okay. Now flux is coming out of in this direction. You are sitting in the air gap. So this pole should be north pole, because from north pole only flux should come out. So north pole of the stator, south pole of the stator. Okay, you need not remember anything there, automatically everything fall in place. Okay. Now north pole, repulsion will happen. North pole, south pole, attraction will happen. South pole, north pole, attraction will happen. So torque developed will be in this direction, electromagnetic torque. So direction of rotation and direction of torque development will be in opposite direction or not? Yes. So at no load happy life, the moment load is connected, some opposition will come. Beyond that opposition, if you rotate, my prime mover rotate the generator such that prime mover supply mechanical power and generator supply electrical power. Now let us think of motor. Okay. Now let me think of motor. Okay. Now in motor, maybe let us consider this as N pole, S pole. What's a big deal? Okay. Now my flux is going to be in upward direction. From N, flux will come out. To S, flux will go in. Now let me keep conductor here. Okay. Now you are supposed to send current in a motor. Okay. In a motor you have to supply electrical power first. So you have to inject current. Maybe let me inject current of dot, for example. It's my wish. Okay. If I inject dot current, then right hand thumb rule. Current is in this direction. So flux should be in this direction. Flux is in this direction means that my armature flux is in this direction. Okay. If armature flux is in this direction, see where flux is going to be in aiding and opposing. So this flux is trying to go in this direction. This flux is, armature flux is in opposite direction. Now my field flux is going in this direction. So armature flux also in the same direction. So as a resultant of interaction of field flux and armature flux, my net resultant flux will be like this. Okay. So what will happen? Always my magnetic flux lines will behave like a stretched rubber band. So if you release stretched rubber bands, torque will be produced in this direction. Okay. Now if you keep your current carrying conductor of dot here, automatically it will push out of it in this direction. Okay. So for example, it is moving in the same direction, motor. Okay. Now it is moving in the same direction. It is moving in the same direction. Torque and speed should be in the same direction. Now let us think of, if this conductor is moving in this direction, how induced voltage will be. Okay, because induced voltage should be against to the direction of current flow, whether we are going to get it or not. Now induced voltage direction, right hand or left hand? Right hand only, because it is generator action. For induced voltage, don't think of it is motor, we have to use left hand. No. Okay, for motor action left hand, for generator action right hand. What is generator action? Generated voltage. Generated voltage will be there in both generator and motor. Getting my point, right? So in motor also generated voltage will be there. In generator also generated voltage will be there. In motor we call it as back EMF. And torque will be produced in both generator and motor, but in motor torque will be aligned with the direction of rotation of the rotor, and in case of generator torque will be against to the direction of rotation of generator. Okay. Now for example, if the same conductor is moving in this direction, moving in the same direction, let us think of induced voltage. Basically these are currents and this is going to be induced voltage. Induced voltage. Now if conductor is moving in this direction, now use right hand rule for the generated voltage. Flux is in this direction. Conductor movement is in this direction because you are allowing the conductor to flow in this direction. Flux is in this direction. Motion of the conductor is thumb is in this direction. So induced voltage is going to be cross. So induced voltage is going to be cross. Now, current direction and induced voltage is in opposite direction or not? Yes. If they are opposite, then only electrical power will be absorbed. That absorbed power will be converted into mechanical power. Now, let me think of motor again. It is not motor action here, it is motor. Okay, so in motor, stationary field, maybe let us think of this as N pole and this as S pole. Okay, let me think of my rotor. Okay, in my rotor I have to keep conductors. Okay, this is rotor. Okay, now in motor what you have to do, you have to supply electrical current first. That current is, for example, dot, cross, these are going to be currents. Okay, so if currents are there, immediately whenever you have current, automatically flux should come, right hand thumb rule. So currents are cross dot. Okay, currents are cross dot, so flux is in this direction. Again you have to sit in the air gap, flux is coming out of the rotor, so it should be N pole of the rotor, this should be S pole of the rotor. Okay, and now this N will get the repulsion, Ns will get the attraction, Sn will get the attraction, so my torque developed will be in this direction. Now, for example, if I strongly hold the rotor not to rotate, then because of this torque development, I will get the twisting moment in this direction. Okay, if I release, it will be accelerated in the same direction or not? Yes, it's a motor. Okay, now for example, it is rotated in this direction. Now let us think of induced voltages. Okay, now in the same conductor induced voltages, conductor is rotating in this direction, so my direction of rotation of rotor is also in the same. Now let us try to find out the direction of induced voltage, right hand. Okay, now flux is in this direction, forefinger flux, motion of the conductor, it is rotating in this direction, so induced voltage will be inside. Okay, they are opposite or not? Yes, that should be. For example, in this case, flux is in this direction, my conductor is rotating in this direction, so conductor is rotating in this direction. Okay, see here, my direction of rotor is in this direction, so my thumb, motion of the conductor is in this direction, and my flux is in this direction, so this is going to be induced voltage. So induced voltage and currents are in opposite direction or not in motor? Yes. Now let us think of stationary, armature conductors, rotating field. Okay, this is stator. In stator, let me have two conductors, and let me consider it as motor only again. Okay, in motor, for example, my rotating part is having field. This is, for example, N pole, S pole. Okay, now in motor you have to give input of currents, so currents are going to be, for example, dot cross, these are currents should be supplied in a motor. So whenever currents are supplied, flux, right hand, so cross here dot here, currents cross here dot here, so flux will be in this direction, flux is in this direction, flux should be in this direction. For the stator, flux is in this direction, you are sitting in the air gap, so flux is coming out of stator, so this should be N pole of the stator, S pole of the stator. Then N repulsion, S attraction, Sn attraction, so torque will be developed in this direction, Ns. Okay, so if torque is developed in one direction, my speed of rotation also will be in the same. Now let us try to calculate induced voltage direction, right hand. Okay, now in this, if I try to calculate induced voltage, flux is in this direction, and see here, pole is being rotated in this direction, field is being rotated in this direction, means that conductor equivalently is rotating in opposite direction. So flux is in this direction, conductor is rotating in this direction, means that my induced voltage should be into the board. These are induced voltages. Okay, so here also currents and voltages has to be in opposite direction. Okay, in this session we discussed, generator 3 ways, First is by taking a single conductor, and second is rotating armature and stationary field, and third is stationary armature, rotating field. Generators are over. Next we considered three types of motor. Like in motor only one conductor I have taken, and the next thing is in motor stationary field, rotating armature I considered, and in the third case in motor means rotating field but stationary armature I considered. Okay, so whatever the conclusions we got here, we have to get it because we derived it starting from conservation of power without knowing all these armature reaction, pole formation and all. Okay, in the next session we will start proper machines.